Welcome back, folks. In today's class, I'll talk about the trig identities and some of the basic trig identities about which we know. Those are sine theta, cosine theta, and tangent theta. Now we're gonna move further than this, and we're gonna try and encompass some of the other identities into our work. So those identities are uh, cot theta. Well, I should write cot here. Cot theta, secant theta, and then cosecant theta. Cosecant theta. So there is a relation between sine theta and cosecant theta, and there is a relation between cos theta and secant theta. There is a relation between tangent theta and cot theta. What's that relation is? Sine theta is equal to 1 upon cosecant theta. Cosecant theta. You can swap the position of sine and cosecant, so you can write cosecant theta is equal to 1 upon sine theta 2. And the second one is secant theta equal to 1 upon cos theta, or you can also write cos theta equal to 1 upon secant theta. If these identities, whatever identities I'm going to talk about in today's class, if they are not given to you in your formula booklet, you can write them also on your formula booklet, but only write down the formulas. Do not write down the questions which I'm going to do in today's class. So something like prove this identity, don't write those on your formula booklet. So tangent theta is equal to 1 upon cot theta. So cot theta will be equal to 1 upon tangent theta. And there is another formula, tangent theta is equal to sine theta upon cos theta. So cot theta will become cos theta upon sine theta. I'll highly recommend you to remember this. Try and memorize them, because if you're going to memorize them, then while solving the question, you will be able to ask yourself which identity you use. And now we're going to talk about some Pythagoras identities. So sine square theta plus cos square theta is equal to 1. If I rearrange, I can also write that sine square theta is equal to 1 minus cos square theta, and I can write cos square theta equal to 1 minus sine square theta. So I can write them in this format also. The next one is 1 plus tangent square theta is equal to secant square theta. So again, I can rearrange them. I can write that tan square theta equal to secant square theta minus 1. The next identity is 1 plus cot square theta equal to cosecant square theta. Now I can write cot square theta equal to cosecant cosecant square theta minus 1. Now here is a very interesting thing which I wanted to show. If you are given a question where only secant theta is used, then always try to convert it into this form. Or when you cos theta is given, you convert it into this form. When you are given when you are given secant square theta, this is secant theta. When you are given a secant square theta, you try to convert it into this form. So try and find out the correlation with respect to the square term. Okay, so please make sure you take a clue from here. When the square is given, you try and use the square identities. When it is given just in the secant form or cosecant form, you try to use these identities at that time. Now there are some other identities also which we're going to talk about. Those identities are sum and difference formulas. So sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. And sine alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. One thing I wanted to tell you here is, sometimes I've seen the student writing sine alpha plus beta equal to sine alpha plus sine beta. That is wrong. You cannot write this way. If this is written in this format, you have to write it in this format. All right. Now the next one is cos alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta. Now cos alpha minus beta is equal to cos alpha cos beta minus sine alpha sine beta. That's another formula. Now the final formula which I will talk about, actually this should be plus. Should be plus here. Tangent alpha plus beta, which is equal to tan alpha plus tan beta divided by 1 plus or 1 minus tan alpha tan beta. And last formula, tan alpha minus beta equal to tan alpha minus tan beta and divided by 1 plus tan alpha tan beta. You can write it in this format. So if any of these identities is not given to you, you can always write them on the formula booklet, but no more than that. Okay, one of these identities you can write on your formula booklet if you wanted to. I think there is double angle after this, so I will talk about them also if I have the time in this lecture. Otherwise I will talk about them in the other lecture. All right, now let's try and solve some of the questions based on whatever identities we talked about. So first question I'm going to take a question from the book. I'm taking the solved example on page 551. It is example 4. So sine x is equal to cos x upon cot x. That's what I wanted to prove it. So how can I prove this? So when you are given a question like this and you will be written prove the identity. Prove the identity. Now, when you are asked to prove the identity, please do not cross multiply. Do not do this. I've seen last year or last semester, shall I say, some of the students they start writing it as sine x times cot x equal to cos x. Then they started solving it. You cannot do that. Prove the identity means you have to take either the left hand side of the equation, make it equal to the right hand side of the equation, or you take the RHS, right hand side of the equation, make it equal to the left hand side of the equation. So the question given to me here is sine theta equal to cos theta upon cot theta. Now I'm going to take this side, or I can write the x form also, or theta, it doesn't make any difference, but I'll put back the x here. Now I'm going to take the right hand side because that gives me more chance of playing with it, and I think I'll be able to convert it into sine x. Let's see how. So cos theta will remain as it is, or cos x remain as it. Cot x is equal to cos x divided by sine x. That's the formula. So I'm going to write it as cos x divided by sine x. Now this sine x is going to go on top, and it will be cos x times sine x upon cos x, and I can cancel the cos x. So sine x will be equal to sine x. So hence I proved the left hand side is equal to right hand side. Now the next question, I'm going to take another example. So tangent theta times cosecant theta is equal to secant theta. That's what I wanted to make it equal to. So now I'm going to take this one because there are two and I can cancel out some of the terms. Tangent theta, I can write it as sine theta upon cos theta. And then let me just check. This is not the cos theta, this is cosecant theta, CSC. And this I can write it as cosecant theta, I can write it as 1 upon sine theta. Again, why I used this sine theta, cosine theta, and sine theta here? Because I'm not given cosecant square theta. If I was given cosecant square theta, I would have used the 1 plus or 1 minus identity, the identity which I've written written it down here. So cosecant square theta, where is cosecant square theta? This one, I would have used this one if it was cosecant square theta, but it is using the cosecant theta, so I went with this one. Oops, cosecant is this one, 1 upon sine theta. So hopefully you understand why I'm using the specific identity. It's not just randomly I'm selecting any. So 1 upon cos theta, which is equal to secant theta. So hence I proved the left hand side equal to right hand side. Now let's look into another identity. Tangent y is equal to secant square y upon cot square y, or cot y shall I say, cot y. Just let me check whether I'm recording the session or not. Yes, I am recording. Okay, so minus tangent cube y. Now I'm gonna take the right hand side and try to come up it try to make it equal to the left hand side. So secant square theta. So it is given now in secant square theta. So and then on the bottom it is cot theta. So I'll see what I can do about this one. I will try and change tangent cube. Is there a formula for tangent cube? No, there is no tangent cube formula. So what I'm gonna try and do is I'm gonna try and write secant. Secant can be secant square theta. What is secant square theta? Is it something in the tangent form? Let's see if it is in the tangent form or not. Secant square theta is 1 plus tangent square theta. That's what I'm gonna use. 1 plus tangent square theta. 1 plus tan square theta. Because I want my end result in tangent form, so I'm trying to convert everything in the tangent form. Cot theta can also be written as 1 upon tangent theta minus tangent cube y. Well, it should be y here, y, and let me sharpen up the pencil a little bit. Okay, now this tangent will gonna go on the upper side, so I can write it as tangent theta 1 plus tangent square y. Well, I don't know why I'm writing theta. I think I'm in love with thetas too much. So this minus tangent cube y. So this is tan y plus tan cube y. Okay, now please make sure you know how to do this algebra. This is like x1 plus x square. So this will become x, and this is going to go here plus x cube. So that's what I'm trying to write. Tangent cube y. This cancels out. Final answer is tangent y. So I've been able to get to the final answer. So I'm going to try and take a couple of problems from the exercise also now. So one of the question is sine theta upon tangent theta is equal to cos theta. So how can I prove the left hand side is equal to the right hand side? That's what I'm going to try and do. So sine theta, so tangent theta can be written as sine theta upon cos theta, sine theta divided by cos theta, and then this two cancels out. This is going to go on top. Cos theta equal to cos theta. So hence I proved the identity. Another kind of a interesting question which I'm going to take right now is sine x uh, sine theta upon cosecant theta plus cos theta upon secant theta is equal to 1. That's what I wanted to prove it as. So now I'm going to try and move the terms around, trying to take the algebra. So sine theta times what can I do? Can I do something about this sine theta and this one? Let me just check the question. This is cosecant, not c. So sine theta upon cosecant, CSC theta. And other side, this is cos theta, and here secant theta. So sine theta, I can write it as secant, I can write it as 1 upon sine square theta, or sine theta, sorry. Sine theta plus cos theta upon 1 upon cos theta. Now this is going to go on top, this is going to go on top. So this is going to become sine square theta plus cos square theta, which is actually equal to 1 because there's an identity which we talked about. Look into the beginning of the class. Sine square theta plus cos square theta is 1. So hence we proved this one too. Now another question I'm going to try and take, that is cos square x minus sine square x equal to 1 minus 2 sine square x, and that's what we will try and prove. So now cos square theta, what can I write cos square theta? So cos square theta plus sine square theta is equal to 1. So cos square theta can be written as 1 minus sine square theta. So I can write this as 1 minus sine square theta minus, I don't know again why I'm writing thetas. I'll write this as x minus sine square x, and then this and this will club together. It's like 1 minus x minus x. So 1 minus 2x. 1 minus 2 sine square x. That will be your answer. Hence, that is equal to right hand side. Alright, so hopefully you were able to understand some of these questions. So I will highly recommend you to do the questions at least from question number 7 up to uh, up to question 54. Up to 54. Try and do on exercise 20.1. So all these questions. If you are asked to factor and simplify, so you can be asked like question number 7 on this exercise. I'll do one of that. So you can be asked a question. So factor and simplify. Factor and simplify this one. So tangent x minus secant x. So factor and simplify. So how can you write it in the simpler form? So what you can do, if you can cancel out some of the terms, try and cancel those terms. So cos theta, I can write this thing as sine theta upon cos theta minus secant x. Well, again, my God, what's happening to my brain? I'll write it as x secant x. And now I will just distribute it. Cos x sine x upon cos x minus cos x times sine x, and then cos x cancels out, and this is not sine, this is secant x. So sine x minus, this is cos x and secant x, cos x times 1 upon cos x. This cancels out. So sine x minus 1, 1 will remain here. So this will be my final answer, sine x minus 1 for this question. That is the simpler form of the work. So these are some of the questions, and as I said, I'll highly recommend you to do some of these questions. I will try and take one more complicated problem from this exercise, and the problem is sine x cosecant x minus sine x equal to cos square x. So this is cosecant, CSC. So now I wanted to make it equal to cos square x. How can I do that? So sine x, I'm going to distribute this inside. Sine x times cosecant x, CSC x minus sine square x. Sine x times sine x is sine square x. So I can write this one as sine x times cosecant will be 1 upon sine x minus sine square x. This cancels out. So 1 minus sine square x, this will be equal to cos square x. So hence we proved that this is equal to cos square x. Left hand side is equal to the right hand side. So I will stop here. In the next class, I will talk about some of the other formulas which I talked in the beginning, like sine alpha plus beta and cos alpha plus beta. I'll try and solve some of the questions on that, and maybe some double angles also. So that's it for today's lecture. I'll see you in another video. Take care.